Bad NTFS performance. Why is it that NTFS performance is so lousy compared to, for example, Linux/X3? Most often I see this when checking out large source trees from Subversion. Checkout takes around 10 to 15 minutes on NTFS, while corresponding checkout on Linux, on almost identical hardware, takes an order of magnitude faster, 1 to 1.5 minutes. Maybe this is specific to handling lot of small files and NTFS is better when it comes to large files, but why should that be? Wouldn't improving NTFS performance for small files be hugely beneficial for Windows performance in general? Edit. This is not meant as a NTFS sucks compared to X3 inflammatory question. I'm genuinely interested in why NTFS performs bad in certain cases. Is it just bad design, which I doubt, or are there other issues which come into play?
NTFS has this thing called a master file table. It sounds really cool when you read about it. You can see that X3 performs alright up to about 95% disk use, while the existence of the MFT means that NTFS doesn't really want you to use more than 90% of your disk. But I'll assume that's not your problem, and that your problem is with the many operations on many small files. One of the differences here is what happens when you create a small file. If a file is smaller than a block size, it is not written to its own block but rather is stored in the MFT. This is nice if the file stays exactly the way it was when created. In practice though, it means that when SVN touches a file to create it, then adds to that file, removes from it, or just modifies it by not enough to move it to its own block, the operation is pretty slow. Also, just reading lots of small files puts some stress on the MFT where they all reside, with multiples per block. Why would it do this? It's preemptively avoiding fragmentation and using more of the blocks more effectively, and in general that's a good thing. In X2 and 3 by contrast, file blocks for every file are stored next to where the directory metadata is for the directory they're in, when possible, if your disk is unfragmented and you have about 20% space free. This means that as SVN is opening up directories, a number of blocks get cached basically for free in that 16 MB cache on your drive, and then again in the kernel's cache. Those files might include the SVN file and the revision files for your last update. This is handy since those are likely some of the files SVN is looking at next. NTFS doesn't get to do this, though large parts of the MFT should be cached in the system, they might not be the parts you will want next.
Well, your particular problem is because Subversion itself comes from the Unix world, the Windows version therefore assumes similar performance characteristics. NTFS performance really isn't great with gazillions of small files. What you are seeing is simply an artifact of something designed for a particular operating system with performance assumptions on that operating systems. This usually breaks down badly when taken to other systems. Other examples would be forking versus threading. On Unix, Flex, the traditional way of parallelizing something is just to spawn another process. On Windows, where processes take at least 5 times longer to start, this is a really bad idea. In general, you can't just take any artifacts of a particular OS to be granted on any other one with vastly different architecture. Also, don't forget that NTFS has many file system features that were absent in Unix file systems widely in use at that point, such as journaling and a clause. Those things come at a cost. Someday, when I have lots of free time, I was planning to write a SVN file system module which takes advantage of features you have on NTFS, such as transaction support, should eliminate the touching millions of small files issue, and alternate data streams, should eliminate the need of the separate .svn directory. It'd be a nice thing to have, but I doubt the SVN devs will get around implementing such things in the foreseeable future. Side note, a single update on a large SVN repository I am using took around 250,000 file operations. Some tiny voice tells me that this is really much for 24 files that changed.
Here's Microsoft's info on how NTFS works. It may be overkill for what you're looking for, but studying it may shed some light on what scenarios NTFS has problems with.
If you want to support the development, please consider subscribing.